Hi, I'm Ismail. I will show you how to capture data through a single analog channel. So we will use the ADC, uh, the ADC 0 and input through the preset. We use a preset or we use the Arduino multifunction board. Okay, so plug in probably your Arduino multifunction board for this uh, uh, presentation. Alright, so first we go to the board. What we see to go is to set the clock configurations. For example, here I want to set the clock to 60 meg. 60 meg. So because of this is very important for the ADC because the ADC for F401 it is connected to APV2. So we need to know the frequency at the APV2 peripheral, not timer peripheral. So here is 60 meg. So what we can go, so go to the Excel. So we have the time sampling equal to EDC clock multiply T convolutions and divide then minus ADC cycle, right? So this is the formula got from my notes, right? So you can see here the notes here, right? So how I derive it. Alright, so for this example, so our PC clock is 60 meg exponent 6, right? Assume that say we need the time to the resolution for you can change it 10 bit or 12 bit for example. So ADC clock will change. Again, this is also depends on the type of the ADC, right? So the processor, right? So for F4 series, when it sets to 12 bit, the ADC cycle will be 15, right? So it's now I'm going to work with 10 bits, so set it to 10 bit, and then the divisor is up to you, right? Divisor, okay. So if the divisor greater than 8, for example, so you got lower T sampling. Actually, this is just to fit the parameters, the parameters inside the ADC later on. You see it, and then the T convolution is the time for uh, the time taken to sample the signal, right? The signal conversion time. So conversion time is depends on the application. If you need the time at 10 microsecond, for example, in this our examples, then just set it to 10 exponent negative 6. So here we got the T samplings at 62, 62. So again apply the formula uh, of 3 later. So now we go to the pin out and configurations, click to ADC, then we set to in 0, right? Because you're going to use the ADC PE0 that's connected to the preset, right? Then okay, you can move this one up, right? Move it up, right? So you can see here clearly. So the first for the parameters, PC clock must be divided by 8 because you set it to 8. The ADC is to 10 bit, right? Then for the data alignment, we need the right alignment. If you put it in left alignment, then you will multiply by the number of so 2 power of 8 because our ADC low and ADC high, we combine it with 16 bit. So for the 10 bit, if you move it to the left, so it's move to bit 15, that means you multiply. You shift bit 9 to bit 16, 15, so you move it by 6. So instead of your rate, let's say 10, but you multiply, you got 10 power multiply with 2 power of 6, and 2 power of 6, because you shift to the left by 6 times. Okay, so set to right, like alignment. Scan conversion because we are working with DMA, not with DMA, so this disable. Continuous conversion is also disabled. Discontinuous also disabled. DMA disable. End of conversions. Okay, we can select either, right? This one, right? So again, because of we work with the ADs, with the interrupt mode in interrupt mode, so not in DMA, so set it to end of single channel conversions. Alright, so that is for DC sampling. For the ADC regular conversions, right? This one, second one. So number of conversions set to 1 because we have one only. Regular conversion launched per software, right? Launched per software. We can have the ones that launched by timer, right, and so on, right? So that this one I will show later in the I will show it later. And external trigger none because we use the internal trigger. And rank, click to rank. So we have rank the first rank 1, okay, because we have 1, so we have 1. If you have 2, let's say we have rank 1 and rank 2. So channel must be set to 0 because this channel 0. Then 3 cycle, right? No, this cycle should be set to more than 62 because we calculate it already here. So we go here, find out more than 62. So we select 84 cycle, right? Alright, then go to, okay, others no, because we not use ADC index consumer, no watchdog, right? That's all for that. Okay. Then we go to the NBIC setting, enable it, okay? Enable it because we work with in ADC in interrupt. Then because we're going to use the Circom 1, okay? Circom 1 so USAT. So connectivity set to USAT 2, right? Then mode asynchronous, flow control, no, we don't have, we not use flow control. Then parameter setting, okay, accept it, 115. Then go to NBIC, enable it. That's all. Maybe if you need to monitor either your code is working or not, then you can click PA5 if you like, but I don't want it. So generate it. So once you generate it, then it will, right? It will, so the first thing that we need is to move the okay, the driver that we need, right? The driver that we need. So the first one, the driver that we need is we go to the driver. So we need that two driver. First one is right. The first one that we need is the Shellcom one. The second one that we need is the user tick. Remember, press control, right? Press control, and then you can move it to AC to include, right? Copy it. Then after that, then you have this, right? It's inside here, and then move your C file, move it without control, without control. Control is to copy, this one to drag. Then after that, then open up the Circom one, C, because we did this character, right? Buffer, P, go to bin, right? Then we need to include that to a file, found INC, double quote, user tick, enter. Then we need to include the one that we have is serial com 1. Then go to the PV, okay, type extend, remember that TX buffer must be placed in the global, in global label. Place it here, right? So now we can use it in our code. So this is the basic, right? The most basic setup for that. Then we go to the right here in the user tick. So maybe we want to transmit, right? Transmit something like, okay. This is an example of single channel ADC, right? ADC, right? ADC in interrupt. Okay, then of course we're going to use the statistic. So you type as sys, right? Set statistic. We're going to use one, right? Only one, because we want to trigger the the uh, the ADC, right? By software, right? This is all. So once we run this, then we can see this. This is an example of single channel ADC in interrupt mode. Then we can if we set the statistic, right? Then each, right? Then each if get statistic. So each say 100 millisecond, we're going to, right? Sorry, 0, because the first one that we have statistic 0, right? Tick 0. Then we read it each 100 millisecond. Then we start to HAL underscore. Now we work with the analog, right? Analog HAL analog. No, ADC, sorry, ADC underscore, right? Start, right? Start IET, right? Because we work in IT. The handler is ampersand HADC. And before I forgot to, right? So once we set the ADC and the UART here, so we have the handler, right? HADC1 for the ADC and then UART2 for the UART. Okay, right, that's all. So in the if you remember, right, when we talk about interrupt, right? So once it is interrupted, then we need the callback, and we need the callback, or we need the interrupt service routine. So there's all code for that, right? That just to twist to trigger the ADC, and then we go back to driver, click to HAL driver, click to source. From here, from the list, click to open HAL ADC. Then if you can see it, something like this, right? You go to window, show view, then outline it. Okay, so it will outline you. So what I need here is the what we call as the HAL ADC convert conflict. This one, convert complete fallback. So click on it. You can copy all, but I suggest you just copy this one. Copy it, go to main, and then you can place it anyway, right? But I place it in the top of the code, in the code begin 0. All right, then okay, we can write code when it is interrupted, right? So first thing first, we need to copy the data from the from the ADC, from the result register. So we type in here, they say you have, okay, because it is 10 bits, so you need to use UINT 16. All right, so see analog in digital, right? Digital value, right? The one that we got is digital value. So we read it from HAL underscore ADC underscore get value. Okay, so here we have the get value here, right? API. This API return us the contents of ADC high ADC result register, result register, low and high. Enter it. Then select the handler, semicolon. Okay, after we read it, maybe we need to, maybe we can stop it, right? So we stop it. HAL underscore ADC underscore stop, control space. Then you got stop IT HADC 1 semicolon. Then I want to display it at the value. So we can write down something like printf the value, right? What the value is into tx buffer. Okay, so we want to print it into tx buffer. Double quote /n/r. So the first value that we have is from digital, right? Digital value is equal to percent u, right? Unsigned. Then maybe we can type t, and then we write again the second one, analog value. Okay, analog value equal to, okay, percent, right? F float, right? Float. We're not doing that. If you want to use double, LF, up to you. Okay, up to you. Okay, say I want to use float F, right? Comma. So we're going to display digital value and comma, we want to display. Alright, so because of the, right, we don't we need to know the SR, right? SR. Okay, see this SR, right? SR. SR is calculated by BREF positive minus BREF negative. BREF positive minus BREF negative divided by, okay, okay, BREF positive minus BREF negative divided by 2 power of n number of resolutions minus 1, right? Minus 1. So in our case, we have BREF of 3.3 and BREF negative of 0. So 3.3 over 2 power of n, 2 power of 10 is 1024 minus 1. That means divided by 1023. So if you calculate it, you got this, right? This is the value is 00. Okay, you can copy if you do like, right? Copy it. Just copy. Then go to your, then type in data value multiply by, right, multiply by that, right, the resolution. Okay, but remember to make this become float and typecast it, and then transmit whatever inside the text buffer, right? Okay, so this is okay. Now we use the percent %f, right? Percent %f of print of float. So if you use float, okay, if you use float, you go to project, then go to properties, then go to C++ build, then click setting, then go to the MCU setting, then enable these two, okay? Use float with printf, use float with scanf. Okay, apply and close. Then That's all, right? Compile it. Okay, once you download it, then reset the processor. Okay, this is an example of single channel ADC. Then we can change this one, right? Change it, the presets. Hmm. Okay, you can change the bit code here. Floats, right? You just print to what was to points. You download it. Okay, then you can vary maximum of 3.3 and change to minimum of, this is 20 turn, 20 turn preset. So you need to turn it 20 times until you hear something like tick, small tick. That's the maximum. Okay, so you can set it to. Okay, that's all. Bye bye. If you want more, come to KL.